Preparing for a network engineering interview? You've reached Candy Mentor, and this video is for you. We'll walk through 25 key questions you're likely to face. For each question, you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What happens when you type a website URL in a browser and press enter? First, the client resolves the domain using DNS to get an IP address. Then it opens a TCP connection, and for HTTPS, negotiates TLS. The browser sends an HTTP request. Packets are routed through gateways, NAT devices, firewalls, and ISPs until they reach the server. The server replies with content, which returns through the network path. I also mentioned caching, CDN involvement, and troubleshooting points like DNS failure, latency, or blocked ports. While answering, focus on the end-to-end packet journey. DNS resolution, TCP or TLS handshake, HTTP request, routing, NAT, firewalls, server response, and how the browser renders content. Question 2. Explain the OSI model and how you use it while troubleshooting network issues. The OSI model is a troubleshooting framework, not just theory. I usually start at layer 1. Cables, optics, power, and link lights. Then I check layer 2 with MAC learning and VLANs. Layer 3 with IP addressing and routing. And layer 4 with ports and TCP handshakes. Higher layers involve DNS, HTTP, authentication, or application logs. This approach prevents guessing and helps narrow the fault quickly. Make sure to cover all 7 layers, map common protocols and devices to each layer, and explain how layered troubleshooting helps isolate physical, IP, transport, or application problems. Question 3. What is the difference between TCP and UDP, and when would you use each? TCP is connection-oriented and reliable. It uses handshakes, acknowledgements, sequencing, retransmissions, flow control, and congestion control. I use it when correctness matters, like HTTPS, SSH, SMTP, or file transfers. UDP is connectionless and lightweight, with no built-in delivery guarantee or ordering. It fits DNS, VoIP, gaming, and streaming, where low latency matters more than perfect delivery. The choice is really reliability versus speed and overhead. In your answer, compare connection setup, reliability, ordering, retransmission, overhead, latency, flow control, congestion control, and practical examples like web traffic, VoIP, DNS, and streaming. Question 4. How does ARP work, and what problems can occur with it? ARP resolves an IPv4 address to a MAC address on the local network. If a host wants to reach another local IP, it broadcasts an ARP request, and the owner replies with its MAC. For remote destinations, the host ARPs for the default gateway. Problems include stale ARP entries, duplicate IPs, and ARP spoofing attacks. In enterprise networks, I mitigate risk using DHCP snooping, dynamic ARP inspection, static entries for critical systems, and monitoring. Be sure to mention IP to MAC resolution, broadcast requests, ARP cache, same subnet communication, default gateway behavior, gratuitous ARP, ARP spoofing, and mitigation techniques like dynamic ARP inspection. Question 5. What is the difference between a switch, router, and firewall? A switch connects devices in the same LAN and forwards frames using MAC addresses. A router connects different networks and forwards packets using IP routes. A firewall controls traffic based on security policies, often with stateful inspection, NAT, and application awareness. In practice, these roles can overlap in modern devices, but the intent differs. Switching provides local connectivity, routing provides path selection, and firewalls enforce trust boundaries. While answering, distinguish forwarding based on MAC addresses, routing based on IP addresses, and security policy enforcement. Include Layer 2, Layer 3, stateful inspection, NAT, segmentation, and deployment examples. Question 6. How do VLANs work, and why are they used in enterprise networks? VLANs split a physical switch into multiple logical networks. Each VLAN is a separate broadcast domain, which improves security, performance, and manageability. Access ports carry one VLAN for endpoints, while trunk ports use 802.1q tags to carry multiple VLANs between switches or to routers. To communicate between VLANs, we need Layer 3 routing. Common issues include wrong VLAN assignment, trunk misconfiguration, native VLAN mismatch, and missing gateway configuration. Make sure to cover logical segmentation, broadcast domains, 802.1q tagging, access and trunk ports, inter-VLAN routing, security benefits, scalability, and common misconfigurations like native VLAN mismatch. Question 7. What is subnetting and how would you calculate usable hosts in a subnet? Subnetting divides a larger IP network into smaller logical networks. With CIDR, the prefix length tells us how many bits are fixed for the network. The remaining bits are host bits, so usable IPv4 hosts are 2 to the power of host bits minus 2, excluding network and broadcast addresses. For example, /24 has 8 host bits, so 254 usable hosts. Good subnetting reduces waste, controls broadcasts, and supports route summarization. In your answer, explain network bits, host bits, CIDR notation, subnet mask, network address, broadcast address, usable host formula, route summarization, and why subnet planning matters operationally. Question 8. What is the difference between static routing and dynamic routing? Static routes are manually configured, predictable, and useful for small networks, default routes, or controlled paths. Their weakness is maintenance. If a link fails, they do not automatically adapt unless tracking is configured. Dynamic routing protocols exchange reachability information and recalculate paths after failures. They scale better but add complexity and require tuning. I usually prefer static routing for simple edge cases and dynamic routing for resilient enterprise or service provider networks. Be sure to compare administrative control, scalability, convergence, maintenance effort, failure handling, route preference, and examples using static routes, default routes, OSPF, EIGRP, ISIS, and BGP. Question 9. How does OSPF choose the best path? OSPF is a link state routing protocol. Routers form adjacencies, exchange LSAs, build the same link state database inside an area, and run Dijkstra's SPF algorithm. The best path is chosen based on lowest total cost, typically derived from interface bandwidth. OSPF scales using areas, with Area 0 as the backbone. On broadcast networks, DR and BDR reduce adjacency overhead. Troubleshooting usually starts with neighbors, area IDs, authentication, NTU, and timers. While answering, cover link state behavior, LSAs, areas, SPF algorithm, cost calculation, router ID, adjacency formation, DR and BDR on broadcast networks, and convergence behavior. Question 10. What is BGP, and why is it considered different from IGP protocols? BGP is the routing protocol of the Internet. Unlike IGPs such as OSPF, which find shortest internal paths, BGP focuses on policy-based routing between autonomous systems. It uses attributes like AS path, local preference, MED, communities, and next hop to choose routes. eBGP connects different organizations, while IBGP distributes external routes internally. BGP converges more slowly, but it is highly scalable and gives operators strong control over traffic engineering. Make sure to explain autonomous systems, path vector routing, eBGP versus IBGP, policy-based decisions, attributes like AS path and local preference, internet routing, and slow but stable convergence. Question 11. How would you troubleshoot a user who says they cannot access the internet? I first confirm whether the issue affects one user, a subnet, or the whole site. Then I check link status, IP address, subnet mask, gateway, and DNS settings. I ping the gateway, then an external IP, then a domain name to separate connectivity from DNS. Next, I inspect routing, firewall logs, proxy settings, and NAT. If needed, I run traceroute or packet capture. The goal is to isolate the failing layer quickly. In your answer, show a structured workflow. Verify scope, physical link, IP configuration, gateway reachability, DNS, routing, firewall, proxy, NAT, packet captures, and escalation criteria. Question 12. What is NAT? And what are the differences between static NAT, dynamic NAT, and profit after tax? NAT translates private addresses to routable addresses, commonly at the internet edge. Static NAT maps one private IP to one public IP, often for servers. Dynamic NAT maps private hosts to a pool of public addresses. Profit after tax, or overload, lets many internal hosts share one public IP by using different source ports. Profit after tax is most common because public IPv4 space is limited. The trade-off is added state, logging needs, and occasional application compatibility issues. Be sure to discuss private versus public IPs, address translation, one-to-one mappings, address pools, port overloading, firewall edge usage, limitations, logging, and troubleshooting implications. Question 13. What is DHCP, and what is the DORA process? DHCP automatically assigns IP configuration to clients. The DORA process is discover, offer, request, and acknowledge. A client broadcasts discover, the server replies with an offer, the client requests that address, and the server acknowledges the lease. DHCP also provides options like gateway, DNS, domain name, and lease duration. Across subnets, DHCP relay forwards requests. Failures usually involve exhausted scopes, missing relay configuration, VLAN issues, or rogue DHCP servers. While answering, cover automatic IP assignment, discover, offer, request, acknowledge, lease time, scope, options, relay agents, reservations, exclusions, and common DHCP failure scenarios. Question 14. How does DNS resolution work, and how would you troubleshoot DNS issues? DNS translates names into records such as A, AAA, CNAME, MX, and TXT. A client usually asks a recursive resolver, which checks cache or queries root, TLD, and authoritative servers. Troubleshooting starts by testing the resolver, then querying authoritative servers directly with DIG or NSLOOKUP. I check TTLs, wrong records, propagation, split horizon DNS, search suffixes, and firewall rules blocking UDP or TCP 53. DNS issues often look like application failures. Make sure to include recursive and authoritative servers, root and TLD lookup, caching, record types, TTL, split DNS, tools like NSLOOKUP or DIG, and common misconfigurations. Question 15. What is spanning tree protocol and what problem does it solve? STP prevents layer 2 loops in switch networks. Without it, redundant links can cause broadcast storms, duplicate frames, and MAC table instability. Switches exchange BPDUs, elect a root bridge, and block selected ports to create a loop-free topology. RSTP improves convergence compared with classic STP. In production, I control the root bridge placement, enable portfast only on edge ports, use BPDU guard, and prefer routed links for large-scale designs. In your answer, discuss layer 2 loops, broadcast storms, root bridge election, port roles and states, BPDU exchange, RSTP improvements, convergence, and design best practices. Question 16. What is EtherChannel or link aggregation, and why is it useful? EtherChannel bundles multiple physical links into one logical link. It increases available bandwidth, provides redundancy, and prevents STP from blocking individual parallel links. LACP dynamically negotiates the bundle, while static mode requires exact manual configuration. Traffic is load balanced using hashing, usually based on source and destination MAC, IP, or ports, so one flow may not use every link. Common issues come from mismatch speed, duplex, VLANs, trunking, or LACP mode. Be sure to mention bundling physical links, increased bandwidth, redundancy, load distribution, LACP versus static configuration, hashing behavior, switch compatibility, and troubleshooting mismatched parameters. Question 17. How would you secure network access at the switch port level? At the access layer, I start by disabling unused ports and placing them in an unused VLAN. For active ports, I can use 802.1x for identity-based access, or port security with MAC limits where 802.1x is not available. DHCP snooping and dynamic ARP inspection protect against rogue DHCP and ARP spoofing. BPDU Guard protects edge ports from accidental switches. The best design combines authentication, segmentation, monitoring, and clear exception handling. While answering, focus on port security, 802.1x, MAC limits, sticky MAC, shutdown or restrict actions, DHCP snooping, dynamic ARP inspection, BPDU Guard, and unused port handling. Question 18. What is QoS, and how would you prioritize voice traffic on a network? Core OS manages traffic behavior during congestion. For voice, I classify and mark packets, usually with DSCP EF, then trust markings only from approved devices such as IP phones. On uplinks and WAN edges, I configure priority queuing to reduce latency and jitter. I may also shape traffic to match provider rates and avoid drops. QoS does not create bandwidth, it decides which traffic wins when links are congested. Make sure to discuss classification, marking, DSCP, queuing, policing, shaping, congestion management, jitter and latency requirements, trust boundaries, and validation with monitoring tools. Question 19. What is the difference between latency, jitter, packet loss, and bandwidth? Bandwidth is capacity, latency is delay, jitter is variation in delay, and packet loss is missing traffic. A backup job mainly needs bandwidth. Voice and video are more sensitive to latency, jitter, and loss because real-time traffic cannot wait for retransmissions. Web browsing can tolerate some delay but suffers with high loss. I measure these using ping, iPerf, NetFlow, packet captures, synthetic probes, and application monitoring. In your answer, define each metric clearly, explain how they affect applications differently, include examples like voice, video, backups, and web browsing, and mention measurement tools. Question 20. How would you troubleshoot intermittent packet loss between two sites? Intermittent loss needs evidence over time. I start with continuous ping or synthetic monitoring between endpoints, then test hop by hop with traceroute, NTR, or path monitoring. I check interface counters for CRC errors, drops, overruns, duplex issues, and congestion. Then I review routing changes, firewall logs, QoS policies, MTU problems, and carrier circuit health. Packet captures help prove whether packets leave one side and arrive at the other. Be sure to describe isolating the path, checking interfaces, errors, congestion, routing changes, MTU, carrier circuits, firewall drops, packet captures, continuous monitoring, and correlation with time or traffic patterns. Question 21. What is MTU, and how can MTU mismatch cause network problems? MTU is the largest packet size an interface can send without fragmentation. If a path has a smaller MTU, packets may need fragmentation, or if the DF bit is set, they are dropped and should trigger ICMP feedback. Problems appear with VPNs, tunnels, or cloud links because encapsulation adds overhead. Symptoms include some sites loading partially or large transfers failing. I test with ping payload sizes and fix it using proper MTU or MSS clamping. While answering, cover maximum transmission unit, fragmentation, path MTU discovery, DF bit, ICMP blocked issues, tunnels and VPN overhead, symptoms, and troubleshooting with ping size tests. Question 22. How does a VPN work, and what are common VPN troubleshooting steps? A VPN creates an encrypted tunnel over an untrusted network. With IPsec, peers negotiate security parameters, authenticate using certificates or pre-shared keys, and establish SAs for encrypted traffic. Troubleshooting starts with reachability between peers, then IKE proposal matches, authentication, NAT traversal, firewall ports, interesting traffic selectors, and routes. If phase 1 is up but traffic fails, I check phase 2, ACLs, NAT exemptions, and packet counters. Make sure to include encryption, tunneling, authentication, IPsec or SSL VPN, IKE phases, proposals, pre-shared keys or certificates, routing, NAT traversal, firewall ports, and log analysis. Question 23. What is high availability in network design, and how would you avoid single points of failure? High availability means the network continues operating when a component fails. I design redundancy at multiple layers: dual power, redundant switches, diverse uplinks, dynamic routing, firewall HA, and first hop redundancy like HSRP or VRRP. For WAN, I prefer diverse carriers and physical paths. Redundancy must be tested, not assumed. I also watch convergence time, asymmetric routing, and operational complexity, because a resilient design still needs to be understandable during incidents. In your answer, discuss redundant devices, links, power, routing protocols, first hop redundancy, clustering, diverse carriers, failover testing, monitoring, convergence time, and balancing resiliency with cost. Question 24. How would you approach designing a network for a new office with 500 users? I begin with requirements: user count, applications, voice, video, Wi-Fi density, security zones, internet bandwidth, and growth. Then I design VLANs and IP subnets for users, voice, servers, guests, and management. The access layer connects endpoints, distribution handles routing, and the edge provides firewall, NAT, VPN, and internet connectivity. I include redundant links, UPS, monitoring, logging, and documentation. A good office network is secure, scalable, and easy to operate. Be sure to cover requirements gathering, user and application needs, VLANs, IP addressing, wireless, switching, routing, internet edge, firewall policies, redundancy, monitoring, documentation, and future growth. Question 25. Which network monitoring tools and methods do you use to detect and diagnose problems? I use layered monitoring. SNMP or streaming telemetry tracks interface status, CPU, memory, errors, and utilization. Syslog and traps show events. NetFlow identifies top talkers and traffic patterns. Synthetic probes test user experience, while packet captures validate packet-level behavior. I also rely on configuration backups and change tracking because many incidents follow changes. The key is baselining normal behavior and creating alerts that are actionable, not just noisy. While answering, mention SNMP, Syslog, NetFlow, telemetry, packet captures, synthetic checks, alert thresholds, dashboards, baselining, configuration backups, log correlation, and avoiding noisy, unactionable alerts. If you are still with us, congratulations! You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.